All right, today we are looking at the concept of simplifying algebraic expressions. You should be on page 387. This is lesson 5. So we've talked a little bit about algebraic expressions. They are expressions that include both letter values and number values. So example, 3x plus 5 is an algebraic expression. A plus 9 is an algebraic expression. What makes them algebraic is this idea that there's an unknown quantity. That unknown quantity can actually represent anything. So just as a quick reminder, if we had, go ahead and draw yourself a T-chart right here. If we had A plus 9, that would change based on the value of A. So if A was 1, we'd have 1 plus 9, which would give us 10. And if A was 10, we'd have 10 plus 9, which would give us 19. And if A was negative 5, we'd have negative 5 plus 9, which would give us 4. Notice, with just one algebraic expression, A plus 9, we can end up with an infinite number of answers depending on what A is. So now we're going to look at simplifying these expressions, and let's go to this real world link. Patricia, Hugo, and Son work in a music store. Each week, Patricia works 3 more than twice the number of hours that Hugo works. Son works 2 less hours than Hugo. We can see 3 different representations of hours here. So let's read it one more time. Patricia works 3 more than twice the hours of Hugo. So since it's being compared to Hugo, we're going to start Hugo as just the simple x. So if we looked at an expression to show how much Hugo works x hours. Patricia works, see it one more time, 3 more than twice the number. 3 more than twice the amount. So she works 2 times what Hugo works plus 3 hours more. And Son works 2 hours less than Hugo. So since Hugo's number is x, Son's number is x minus those 2 hours. So model the total number of hours that Patricia and Son work. Well, we know that Patricia works 2x plus 3, and Son works, so we have that much more, x minus 2. Now, we don't need parentheses here. We can use them temporarily to help us divvy out or to help us divide out which each one is. So this is Patricia, and we just pulled this right from this expression, 2x plus 3, and this is Son. We're going to go ahead and we're going to rewrite this before we go any further. Think back to yesterday's lesson where we talked about the advantage of having everything as addition. And this is going to be one of those places where that would be helpful. So we're going to go through and we're going to think of this as 2x plus 3 plus x plus negative 2. We simply took this amount for Son and made it into plus negative 2 instead of minus 2. All right, so now let's go ahead and we're going to do a process that is called combining. Go ahead and write this down. Combining. I always misspell combining. I leave off the extra ing. Combining, there we go, like terms. That means, that might sound fancy, but here's what it means. Put the same kind of things together. And you'll see what I mean by that. Go ahead and get this written in. Put the same kind of things together. And remember, at any point, if you need to, you can stop the video, pause it, get your notes caught up, and then pick up the video again. So when we look at what we have two kinds of things here. We have x's. We have two x's here. We have an x there. So one kind of thing we have are x's. The other kind of thing we have are ones. We have 3 ones here. We have negative 2 ones here. So we have x's and we have ones, or numbers. For the x's, we have those 2 x's and we have another x, which means, since those are all added amounts, positive amounts, we have 2 x's plus 1 more x. We have 3 x's altogether. For the ones, and this is where the advantage is of making everything into addition, we have 3 ones, and then we can see we have 2 negative ones. So if you have 3 positives and 2 negatives, that simplifies out to 1. And when we put everything together, we have the 3 x's and the 1. Remember, in mathematics, when you see a plus sign, you can think of it as and. So if I go back to my list here, I have 3 x's and 1 positive. So that's the idea. That's the basics of combining like terms. And we're certainly going to discuss that more as we move on. So head to the next page. So as we look at identifying parts of an expression, there are a couple different things we want to keep track of. First, the number of terms. Each of these represents a term. Our terms are separated by these addition signs. Then we have what are called like terms. These are x's and these are x's. If we put these into one of those T charts, if I built myself a T chart over here, and I said, what's one kind of thing I have? X's. I would put both this negative 4x into that part of the T chart, and I would put this positive x into that part of the T chart. The other thing we have, and most of our expressions will have this, is they will have some ones. The 12 represents the amount of ones, and there's nothing else to go with it. So if you simplified this, you would end up with negative 4 x's and 1 positive x, negative 3 x's plus the 12 ones. Let me write that down here because that almost looks like it's subtraction. Negative 4x plus the 12 ones. The other things to note are this 12, which is called a constant because 12 always has the value 12, whereas x, remember this x is called a variable. It's called a variable because its value can vary. And then one term that they don't define, but this right here, this negative 4, we call that a coefficient. Go ahead and write this. It's called a coefficient. It's this negative 4 right here. And what that coefficient does is it tells us how many x's. This also has a coefficient, we just don't see it. Its coefficient is the number 1. If I put it over here, I would say that's 1x and negative 4x's, which got me negative 3x's. Go ahead, do this, stop and reflect. Circle the term that's a like term to negative 4x to the 3rd power. Something you could combine with 4x to the 3rd. And what you should have circled is that x to the 3rd. The x to the 3rd is different than the x to the 2nd. These are x squareds. These are x cubes. All right, let's continue on with this idea. So here we go. Identify the terms, the like terms, the coefficients, and the constants in this expression. Well, notice the first thing they do is they change it all to addition. So they put everything, instead of minus 7n, they do plus negative 7n. Instead of minus 4, they do plus negative 4. And then once we have it in that, we can see that all of our terms are separated by these addition signs. So there are 1, 2, 3, 4 terms, the 6n, the negative 7n, the negative 4, and the n, 1n here. The like terms, well, the 6n, the negative 7n, and the n are all like terms. You might think, well, what happened to the negative 4? Well, there's nothing else in the ones column. So again, let's build this for the example. If we were looking at the kind of things we have in this example, we have n's, we have ones, we have 6n's, we have negative 7n's, we have 1n, which, by the way, when we have just one of them, you could show it just as n by itself, or you could go ahead and write that 1 in to help yourself make sure you keep track of that. And then the only item that would be over here in the column of the ones would be that negative 4. So go ahead and pause the video and figure out the terms, the like terms, the coefficients, and the constants for A and for B. All right, so here's the answer to A. You'll notice the very first thing that I did was I rewrote as an addition sentence. Now, if you want to, you can always put parentheses in around your negatives to make them stand out. I just went ahead and wrote mine straight up. So 9y plus negative 4 instead of minus 4 plus negative 11y instead of minus 11y plus 7. So then my terms, once I have this, my terms are everything separated by these addition signs. So my terms are 9y, negative 4, negative 11y, and 7. My like terms are the 9y and the negative 11y. I could combine those. The other like terms are the negative 4 and the 7, because I could combine those. My coefficients, the things that tell me how many variables I have, are the 9, because 9y, so 9y's, and the negative 11, because negative 11y's. And the constants, the things that don't change value at all, are the negative 4 right here and the positive 7 right there. All right, go ahead and do B. Now that you've seen A, maybe that'll help. Go ahead and do problem B. All right, so once again, the very first thing I did was I rewrote it all as addition. So instead of minus 10, I did plus negative 10. Instead of minus 3x, I did plus negative 3x. My terms, once again, are separated by my addition signs. So I have 4 terms, 3x, 2, negative 10, and negative 3x. The like terms are 3x and negative 3x, and the other like terms are 2 and negative 10. I can combine these. I can combine these. The coefficients are this 3 from the 3x and this negative 3 from the negative 3x. And the constants, the things that don't change, are the 2 and the negative 10. So now we've identified all of our parts. Now we're ready to start the idea of actually simplifying. So when we simplify, the idea is that we're going to put all the similar things together. There will be no like terms. If you look at a simplified expression, you'll say, wait a minute, there aren't 2 things with x, or there aren't 2 constants or 3 constants. We've combined them all. So let's take a look at the next page. Here is an expression, 4y plus y. Put it in simplest form. Well, you can put the 4y and the y together. This has a coefficient of 4. This has a coefficient of 1. So 4 and 1 is 5. We get 5 y's. Same idea here. 7x minus 2 minus 7x plus 6. Step 1, make it all addition. Step 2, combine the like things. Well, we can put, let's do our t-chart. And you don't always have to do a t-chart, but I find it to be a really useful way. So this has x's and it has 1's. In the x column, we have, and sometimes what we'll do is, as we use them, we will cross them out. So we have that 7x. We're going to put it in the x's. We have this negative 7x. Notice we've rewritten it so all the like terms are together. We're going to put it in the x's. So 7 negative x's. We have a negative 2. So we're going to stick it over here. And we have a 6. So we're going to stick it over here also. Well, when we combine 7x's and negative 7x's cancel each other out, so we have no x's. Negative 2 plus 6 is 4, and that's where they get their answer of 4. All right, so let's have you try a couple got it problems. And you've got a lot of room to work right over in here to solve these. So go ahead and do C, D, and E. Pause the video, do them. When you turn the video on, I'm going to explain them one at a time so you'll be able to look at what you did, see if you need to do something different to fix your work on D and then on E. Okay, so I took my expression 4z minus z and I rewrote it as 4z plus negative 1z. I find it really helpful to put that negative 1 coefficient in instead of just writing 4z plus negative z, because that reminds me, all right, I've got 4 positives and 1 negative. Anytime I'm adding like terms, what I'm adding are the coefficients. So I'm adding 4 to negative 1, which gives me positive 3, which means my answer here is 3z. All right, go ahead, pause the video, do do D, and I'm going to do my work for D over in here. So do D, and then we'll come back and look at it. If you've already done D, you can go ahead and let the video run. Okay, so I went ahead and brought my original expression over, 6 minus 3n plus 3n. My first step was to rewrite it all as addition. So 6 plus negative 3n plus 3n. Now I'm going to use that t-chart idea because I like the way the t-chart works. It just makes it really easy for me to see the parts. I can see that I have n's here and I have 1's. I have 6 1's. When I put the n's in this problem, I have negative 3n and I have 3n. Whoops, I don't have x's. And I have 3n. And negative 3n and positive 3n will cancel each other out, which means I have no n's left. The other thing I had, by the way, so I can go through and I can cross as I use. So I used the 3n, the negative 3n. I used the 3n. The other thing I had was I had the 6 1's. So when I do this problem, the n's cancel out. I'll put my answer up here in the answer space. All that's left is the 6. In C, what was left was the 3z. All right, go ahead and pause again to do letter E. If you already did letter E and you're ready to check your work, you can just let the video run. Here's my work for letter E. So I brought over the original expression, 2g minus 3 plus 11 minus 8g. I rewrote it all in addition, so 2g plus negative 3 plus 11 plus negative 8g, which means I have 2 categories of things. I have g's the 2G, the negative 8G, and I have 1s. The negative 3, the positive 11. So my G's, 2G, negative 8G. I can think of that as 2 plus negative 8 would be negative 6. So I end up with negative 6 G's. The 1s, I have negative 3 1s, and I have positive 11 1s. Negative 3 plus 11 is positive 8. So my final answer is negative 6G plus 8. And that's our way of combining like terms. Okay, let's look at example 4. So example 4 says the cost of a jacket, J, after a 5% markup can be shown or expressed as J plus 0.05 or 5% of J. Simplify the expression, then determine the cost of a jacket after markup if the original is $35. So when we combine them, we're adding the 1J to the 0.5J. We get 1.5 or 1.05J. We're going to multiply that by 35. That tells us that our jacket after a 5% markup is $36.75. Go ahead and think about that example 4 and do letter F. So here's my expression that describes what's happening. 1J, I put my coefficient, so J, the jacket itself, plus 8% of J is going to give me 1.08J. I'm going to take that amount, the 1.08, and I'm going to multiply it by the 35. Notice my work is the 35 times the coefficient. So 35 times the coefficient, 1.08, gives me 37.8. Now I was multiplying 1.08J. I was just using the coefficient, but still this whole thing is the cost of the jacket now. It's all J, which means the jacket marked up 8% would be $37.80. All right, one more example. I'm on the next page. So there's a concert. You're going to buy t-shirts for $12 each, CDs for $7.50 each. Write an expression in the simplest form that represents the total number you spent. So you'd spend $12. X is going to be the number of t-shirts and CDs. $12 for each t-shirt, $7.50 for each CD. If you bought those, you would end up spending $19.50. So $19.50X, where X is the number of CDs and t-shirts, represents how much you spent. Here's an interesting one. So you have some money and your friend has 50 less. Write an expression in simplest form that represents the total amount of money you and your friend have, and be sure you pick a variable. Remember, you have to pick a variable. In this case, it'll be the variable for you. So let's just write that in. Here's you. What variable will you pick? And then write an overall expression. So pause the video and try that one. Okay, and we're back. So I'm going to use the variable y for you. So you have your money plus your friend has the amount of money you have minus the $50. So the total amount of money that you and your friend have is y plus y minus 50. Y plus y minus 50. The total amount of money is 2y minus $50. So one way to check this kind of work is to say, let's put a number in. Let's just say that you had $75. Well, if your friend had $50 less, then your friend had $25. So altogether, you and your friend would have $100. Let's see if our 2y minus 50 would be $100. So our y was equal to 75. So 2y would be 75 times 2, which is 150. And then we would have the 150 right here minus the $50. And absolutely, that would get us back to our $100. So go ahead and do problems 1, 2, and 3 of these guided practice problems. Pause the video, do the problems, and then I'll turn things back on, and you can check your work. So for number 1, our first step is going to be to rewrite this as all addition, 5n plus negative 2n plus negative 3 plus n. And if it helps, when you rewrite it, you can slide a 1 right there, make it 1n. Our terms, 5n, negative 2n, negative 3, and n. Our like terms, things we could combine, 5n, negative 2n, and n. The coefficients, this 5, this negative 2, and the 1 that would be right here. And the constant is the negative 3. Okay, go ahead now, do number 2. And in number 2, you're not identifying all these parts. In number 2, what you're doing is you're combining the like terms. So you can think about the t-chart. For number 2, step 1, rewrite it as addition. So 4p plus negative 7 plus 6p plus 10. Step 2, go ahead and you can use whatever method you like. I, again, like the t-chart method. I have p's. I have things where p is the variable, and I have 1s. In the p section, I have 4p, and I have 6p. I can add those together, and that's going to be 10p. In the 1s section, I have negative 7 and positive 10. If I add those together, I get 3. And my final answer is 10p plus 3. All right, go ahead and do number 3. So for number 3, when I simplify the expression, I will be taking the g, and I'm going to think of it as 1g plus the 0.07g, and that's going to give me 1.07g. Then I'm going to multiply that, since the cost of my game is $52. I'm going to have 1.07g times 52. It's the 1.07 times 52 gives me 55.64. That is the cost of the game after we've added the 7% sales tax. Okay, you have homework problems. You know what they are from writing them down in your bind reminder or checking them on the website. You can go ahead, whatever time's left, work on those homework problems. Be sure to come back in with work shown and come in with questions about the ones you don't get.